Good day, ma'am. I'm Regina Alarong and I'm from Claver, Ciudad del Norte. So for today's video, I will discuss the region measure of an angle and circular function of a real number. So let's start. Region measure of an angle. Angle is the figure formed by two rays with a common endpoint. We typically use degrees measure when measuring angles. However, we can also use region angle measure as an alternate way of measuring angles in advanced math courses. This measure is based on using a point on the vertex and measuring the arc length compared to the radius. So, what is region? Region, a unit of angle equal to an angle at the center of the circle whose arc is equal in the length of the radius. Understand where regions come from. Let's begin by sketching a circle with radius r. Next, we'll make a copy of our radius and extend this vertically. Lastly, bend your copy of the radius so that it lies on the circle. An angle with its vertex at the center of a circle that intercepts an arc of the circle equal in length to the radius of the circle has a measure of exactly one region. In our image, theta is equals 1 radian. Now, let's apply this concept to an angle in standard position. Let's now extend our concept into the rim of two regions. What would an angle of measure of two regions look like? This angle would now intercept an arc that is equal to twice the radius of the circle. In our image, theta is equals 2 radians. In general, if our angle theta is a central angle of a circle of radius r, and theta intercepts an arc of length, then we can obtain our region measure of theta as theta is equals s over r radians. In this case, where the arc of the length s is equal to the radius, we obtain an angle where theta is exactly 1 radian.
What?
We know that angle of 360 degrees correspond to one complete rotation and one complete circle. We know the formula of the circumference of a circle, or the distance around a circle, is given by c is equals 2 pi radian. Therefore, an angle of 360 degrees, which is one complete circle, intercept an arc equal in length to 2 pi times the radius of the circle. So an angle of measure of 360 degrees is exactly equal to 2 pi radians. Let's suppose we had a straight angle or an angle of measure 180 degrees. This angle is measured is 1/2 of 360 degrees. We can use the above relationship to develop a method for converting between degrees and radians. So divided by 180 degrees. So our example number 1 is, what is 70 degree in radians? To change the degree measurement to radians, we multiply as follow. 70 degrees times pi over 180 equals 7 pi over 18, or equal to 1.22 radians. Number 2, convert 140 degrees to radians. To convert degrees to radian, we Use same process like number 1. 140 degrees is equals 140 times pi over 180 is equals to 7 pi over 9. Number 3, what is 2 radians in degrees? To change this radian measurement to degrees, we multiply as 2 times 180 over pi is equals to 360 over pi, or equivalent to 114.59 degrees. So our last example is, what is 11 pi over 6? Sorry, it's not pi over r over 6, it's 11 pi over 6 radians. To change this radian measure to degree, we multiply as 11 pi over 6 times 180 over pi. 11 times 30 is equals 330 degrees. So our example number 1 is convert each degree measure into radians. So our example is 150 degrees. 150 degrees is equal to 150 times pi over 180 radians. It's equal to 5,150 times pi over 6,180 radians. To get the radian, cancel the 150 and 180. So we obtained 5 pi over 6 radians. Our example number 2 is convert each degree measure into radians. 260 degrees. 260 degrees equals 260 degrees times pi over 180 radians equals to 13,260 pi over 9,180 radians. Cancel. So we get 260 degrees is equals to 13 pi over 9 radians. Circular function of real numbers. So in this lesson, we will review the trigonometric ratio of angles of rotation around the coordinate grid as a continuous circular function. The connection will be made between how the ratio changes as the angle of rotation increases or decreases, and how the graph of the function depicts the change. Objectives: identify the 6 basic trigonometric functions as continuous function of the angle of rotation around the origin. Use reference angle to find exact values of circular function. Circular functions are defined such that these domains are sets of numbers that correspond to measure and region units of the angles of analogous trigonometric function. The ranges of the circular function, like analogous trigonometric functions, are sets of real numbers. These functions are called circular functions because region measure of angles are determined by the length of arcs of circles. Let theta be an angle in standard position, and point P is equals x and y on its terminal side on the unit circle. So we have angle theta, which is the angle in standard position, and we have point P, and this point P is denoted by x and y. So therefore, this is our x and this is our y. To solve this equation, we use SOHCAHTOA. We are familiar with this method since high school. So means sine is equals opposite over hypotenuse. Ka means cosine is equals adjacent over hypotenuse. Then tangent is equals opposite over adjacent. A sine graph. So our hypotenuse is 1 because this is the unit circle, and we know that the unit circle has the radius is 1. So we obtain sine theta is equals y over 1. A cosine graph. The cosine of an angle is the ratio of x over r. So in the unit circle, the cosine is the x-coordinate of the point of rotation. A tangent graph. The name of the tangent function is from the tangent line, which is a line that is perpendicular to the radius of a circle at the point of the circle, so that line touches the circle. For the three reciprocal functions, it gets increasingly difficult to show the segment representation on the unit circle. Cotangent is the reciprocal of tangent x over y. So the tangent had an asymptote. Now the cotangent will be 0. Cosecant is the reciprocal of sine, or 1 over y. Whenever the sine is 0, it will be undefined. Secant is the reciprocal of cosine, or 1 over x. Whenever the cosine is 0, it will be undefined. It also has the same sign of the cosine function in the same quadrant.